Cool, thank you. So obviously gods of live demo haven't been supporting today, mostly because I prepared some slides. Then yesterday, I think Zeit told me that, hey, no slides, only live demo. So I created live demo, but hopefully I still have a few slides. So initially, I wanted to talk about knowledge graphs, but how many of you already tried knowledge graphs? No, okay. Okay. The thing with generally trusting your workspace is that your data is in various places. SharePoint, Snowflake, Postgres, emails, Wiki, or Confluence. Probably, do you work in bigger companies? Enterprise? Yeah. Okay. Startups? Okay. Good. Good. So startups usually this, sometimes this, depending. Definitely not SharePoint, too expensive. And over the last 4 years, I was wondering like how good search could actually go. And first of all, when I think about the search, we are thinking about searching for the exact words. And we could use something like regex. Some people would call it Elvish. For us, it's just regular expressions. And other non-regex options would be exact match. So we look for exact words, fuzzy search, n-grams. N-grams is like when you have your search box and you type in something and it shows you alternatives. Like some years ago, we had a lot of memes of people typing in and Google n-grams showing crazy stuff. We could do also lexical search like greps, AWKs, and other things like that. And obviously, one of the word searches is embedding searches. And embeddings are actually used for RAGs. And now RAG is more or less dead. Let's do advanced RAG. It was something that I started to work on 2024. And suddenly we add multiple layers to RAGs for retrieval, like query rewriting. So we don't assume that our user knows what they are asking for. We use hallucination to hallucinate answer. And then within our documents, we look for this answer. So it's kind of contradictory, but it's taking benefits of the hallucination. We could do fan out, so-called multi-query. So we ask the same question multiple times. That's something I will show you today. Re-ranking is mostly if you have 100 results, we just use top 10, top 5 scaled. Actually, re-ranking could be done by LLM, but it's expensive. So there is a custom version of LLM's replicular functions doing that. And hybrid search where we use word, keywords, or sparse search and connect it with dense search like embedded retrieval. Plus, my favorite retriever is parent document retriever, where we aggregate information from multiple documents, but instead of chunking the documents, we summarize it. And actually today, I will show you a little bit part of that, because what I'm doing is summarize the document and extract features, keywords. And obviously the last one would be agentic RAG, which is the most expensive, the most time consuming. And well, looks like that in complexity. Obviously, most of the system don't require all of those steps. And I even went further and I created my own framework for RAG. It was 2024, 2025, and already these queries were running over 1 minute on normal internet. And I called it SMAR. In Polish means Greece. In English, it's Greece, like from the movie Greece. Because when you are a researcher, you need to have a crazy naming, like clay. In Polish is cegła and various weird things. So it was actually doing, first of all, reflection of the user question, something like we would call right now reasoning. Then it was injecting additional schema of the informations we have, additional context, and translating queries into specific engines. Then we mapped the results and re-ranked them and gave the last result. This thing was actually long because depending how the translation works. Today in the demo, I will show you translation done by LLM. Obviously not the best way to be done right now. It's quite cost expensive, but there are topical translators, for example, for Konrad and others built in example LangChain. And further on, I realized that there is something called RAG Fusion, where people basically apply my concept but they do it on the context formation a little bit further on. So I use context formation already for the queries. And quickly I realized that RAG isn't actually a framework, but it's more of a treadmill because it's super expensive. Retrievals, all the rewritings is expensive. But what you can do is actually work on the performance beforehand, because even if you add agentic, iterative agent, the result, well, it's 3% points. It's not gonna mean much, and cost is quite significant. And when I look at graph racks, I know we are at Neo4j, so graphs are cool. But when I look at graph rack, and this is a research paper, here you can find it, they say that actually using graphs increases the token usage. And we talk about input tokens, which theoretically impact latency, but still it's a cost. So I started to focus on getting knowledge out of the document. So instead of using documents as is, I started to focus on monitoring how the documents behave. Like we started with name entity recognition, NER, co-reference, like you have a text like, hey, pass him the table or something, pass him something. And what does it mean him? LLM doesn't know it if it got just the string. So this is like co-reference. In a way, we are rewriting original documents. Human documents a lot have bullet points. And that's something you get rid of with rewriting to paragraph. We link entities. And this helps also with deduplication of entities. Like there is just one entity of Wikipedia, not Wikipedia PL, ENG, and etc. And we extract crucial events and relation between those events. I'm going quickly because supposedly I should go with a live demo, but the thing is that today world, you can use very cheap LLMs to extract this information using function calling. And with that, instead of focusing on things, we focus on strings. So if we ask for Merkel, Germany, we got Angela Merkel. If we ask for Angela Merkel, we got Angela Merkel. And if we ask for a person responsible for cookie banner, we get Angela Merkel. This one is made up. This one is made up. So what I started to build is very much similar to Palantir, where we have analytics and workflows and integrations on top of ontologies that we built on the graph. I'm using actually Neo4j to map what knowledge we have in our company and connecting different data sources. And underneath, we have the data itself. So we don't collect the data, we only integrate it. So the project right now is called Open Corporate Data Integrator because we integrate the data. And generally, we don't work on it published. Mostly because we have only a few clients in the POC and testing out the solution. So here I created a data stores to make it quick, because this will be code that will be open on my GitHub. So I created a few documents. That's quite a long repo. So I created a few documents about winemaking. So I'm a winemaker from Poland, by the way. That's how I know about AI, because, I'm a farmer. And I created a few documents that already have extracted keywords and knowledge, like what is it about, like fungicide reduction. So this is vine, like grapes diseases. We have winemaking documents and extracted also key features, what this document is about, and diseases of the wine itself, the one that we drink. So we have those three data sets of information. And we would like to run queries against one or more of those. And we don't really want to care about the structures of it. So for this, I'm using Pydantic AI for agents. And we are extracting the information. In the repo, you will see the full extraction. I'm not going to run it here because probably with this internet, it would take ages. But we are using structured outputs and query planning. Like in here, I mentioned to you translation of the queries. So for example, we did one RAG over Kudrant with winemaking terms. And we are using it with a self-query feature. which means that automatically we apply filters based on the initial questions. And set of prompts, set of agents. So we have one agent for extraction of metadata. This is used during ingestion. We have one agent for triage. So whenever we receive a query, we already try to map some of the keywords. Could be done with name entity recognition and NLP. And we have a final responder giving the response. So if we would run one extraction, for example, on a sample document, you would see that here we have some tags as array of text. Let me scroll through boring code. And if we think about mapping of the terms, we could see which of those are happening most common. Botrytis is quite a nasty disease for the wine. The wine smells like old socks. Not nice. So due to this, we put it SQLite because it's the easiest database today for vine diseases and wine diseases. And we can load them normally as SQLite. And then on top of SQLite, what I did is a semantic layer. Here. So this time, semantic layers is, well, it's just SQLite, so it's quite simple database. But if you have like a data warehouse like Snowflake, it's not going to be that easy. In here, we could easily fit it into one prompt, so like an agent instruction. In normal scenarios, we usually have like 5,000, 6,000 lines TOML files concluding what is in specific view in the warehouse. And we include also KPIs and metrics, dimensions, how those things were calculated. And in here, we are doing the repository from the schema of the database. So it's, as I mentioned, it's quite simple. I think I could show it to you. It's in process. SQLite here. It's something very simple. We extracted the keywords here. It's for the sake of the demo. This could be SharePoint, this could be S3, this could be any data source you have, because the whole concept of ontology is agnostic of the data source. The data source needs to know how to query itself. So next we have also Konrad. So we chunk the winemaking. You can see later on the code. I use LangChain text split, character text splitter, extracted metadata for each of those documents. Here we should have it. And it's 58 chunks, if I'm correct. Yeah, 58 chunks in JSON-L. So we have the summary, we have the text of this chunk. Those chunks are quite lengthy, 1,000 characters around. And we seeded the Konrad. For embedding models, this time I'm used Cohere. It's again abstract depending what you want to use. And let's see if we are connected to Konrad. Yes, supposedly we have collection created. So the collection has 58 points, which is correct. We had 58 chunks. Now I created LangGraph. Oh yeah, Neo4j logic here. So we have to render. Actually, I could show it in here. We had to render like our data sets, and we looked on what things are connected. So this is a nice area where you can look at what things you have around. Because in my opinion, right now, it's not important to have data. It's important to know what you have in your data and how the data, what information is shared and how to access it. So we could see, like, for example, Bordeaux is a region of France. We could see that we have wine diseases and vine diseases for Poland. We could see that Germany has only about winemaking, probably about Riesling. So you could see already for this is just 3 data stores and like 15 documents. But generally, you would see already how your data is sharing features. And in case of full keywords, we have 12 diseases, 35 keywords in total, which are not related to region, disease, or anything. Do we have a connection to graphs? Yes. Okay. So LangGraph is quite simple in this case. So first of all, we triage the question from the user. We route it to a specific data source using Neo4j engine. So we basically write cipher based on the triage. And we retrieve through selected domains, for example, whether it's Kudrand, whether it's SQLite, doesn't matter for our use case. I could actually close this one. So graph is rather simple, quite only a few nodes and a tool calling. So let's say we run run a first question. So for Poland, which fungal diseases are main constraint? And here we go. So it's triaged the question quite quickly. It selected wine diseases using graph, and then we get an answer. Second question would be show a sign, tell a French winery that gray rot is already hurting the wine quality. Gray rot is a specific disease also existing both on the grapes and on the wine later on. And again, it's triage the question, triage it at wine disease, because here we are asking specifically about wine, not vine, not the flora. And additional question, we could use multiple data sources, but this one doesn't want to run because of the internet timeouts. Let's see, maybe this time it will. So it triages correctly that we ask for 2 diseases. So, actually it generated. Wow, gods of live demo were with me today. So we are asking how it could help produce the wine quality during even the harvesting. So gray rot here is Boritis, the ones that I told you in the beginning. The French brief says wine sensory quality can decline, etc., etc. So that's the case how you could actually use graphs not as storing information, but storing information about information. So we are suddenly getting one layer above, and we are building modular systems where each system knows how to query its data. And now you have a data steward focused on only one domain. If you would like to check the code, this is linked to my GitHub. After today, it will be published there. So there will be a repository called Knowledge Graphs. And in this Knowledge Graphs, you will have access fully to the code today.